Hello everybody, in today's video I'll tell you about Aleo Protocol, how it works and what problem it solves. At first I'm going to explain you the current privacy problem we currently have on the internet. Then I will show you how blockchain tried to solve this problem and why it doesn't work perfectly. And finally I'll tell you what zero-knowledge proof is and how Aleo solves privacy problem. Let's go! A decade ago, the extent to which we rely on the internet now would have been hard to imagine. Today, however, the majority of our economic and social activity occurs online. The benefits of this change are especially clear amid the COVID pandemic. Businesses that never relied on the internet before are using it to reach new clients and customers in order to remain afloat. Families are using it to stay connected while physically distanced over the holiday season. The consequences of living our lives online is the exponentially growing amount of data we produce. This has been a major driver for better products and better services. But the power that these algorithms and their owners wield through feeding us the news we read, the shows we watch, and the social connections we make cannot be overstated. This trove of data produced by our online interactions has led to the creation of a new economy defined by who owns access to this data and who doesn't. This intangible data economy is massive, larger than any commodity including oil, and just like oil in the early 20th century, data has grown increasingly centralized in the hands of a few companies. These data monopolies not only pose threats to data privacy and censorship. Monopolies are bad for economies. They encourage rent-seeking, stifle growth, depress innovation, and harm consumer welfare. The state of today's internet is a few monopolies that collect vast amounts of data yet fail to deliver a personalized user experience. But how can we expect to fix this without being even more liberal with the data we share? Blockchain technology was, from its inception, architected to be transparent by default. This architecture is a sharp contrast to today's Web 2.0 defined by closed ecosystems owned by corporations that profit from information asymmetry. It would seem that public blockchains eliminate the unique information asymmetry that support the current monopolies of Web 2.0. But in fact, networks that establish transparency by default create their own kind of information asymmetry that costs network participants and demands a solution that is sustainable. Transactions on a public blockchain are visible to everyone, whether they are active participants on the network or not. The fact that these networks are open prevents any single entity from monopolizing user data, as Web 2.0 monopolies do today. However, this opens up new problems. Any person can look at your balance, can find out what actions you are taking. And if someone manages to identify a wallet with some kind of personality, he will be able to know the entire history of your transactions. Worse, it creates opportunities for other network participants to profit from the information we reveal through our transactions. This is not theoretical, it's costing users money today. In short, anyone using a public blockchain network is vulnerable to opportunistic actors in the system. Decentralized networks are vastly fairer than those available through centralized alternatives. However, the examples of front-running and MEV cited above illustrate how information asymmetry still leaves a cost on users in decentralized systems. With a public network, we may have removed the centralized gatekeepers. But now we find ourselves in the dark forest facing not one, but potentially many potential adversaries who could exploit and use our data at our expense. A naive approach to solving this asymmetry on public networks is to hide everything and make the system fully private. But absolute privacy eliminates one of the most significant benefits of an open network – composability. In an open network defined by data transparency, smart contracts can autonomously interact with and access any on-chain information. The DeFi ecosystem, DAOs, and other composable contracts all rely on transparent access to data. Networks that establish absolute privacy by default ensure that no data can be exploited, but also preclude the creation of the incredibly powerful decentralized applications that define why crypto is revolutionary. For example, Zcash gives users complete privacy but limited programmability. Ethereum provides powerful programmability but limited privacy. What we would like is a protocol that is both private and programmable. Such a protocol would ensure that users are not exploited, yet enable powerful on-chain applications and composability between them. This is why we built Aleo. Aleo is the first decentralized open-source platform to enable both private and programmable applications. Through opt-out privacy by default, Aleo enables a sustainable, equitable Web3 world that can meet developer, consumer, and enterprise needs. Aleo uses zero-knowledge cryptography to achieve both privacy and programmability. Zero-knowledge cryptography and zero-knowledge proofs allow third parties to verify the truth of a piece of information without us needing to reveal it directly. Aleo uses this at the foundation of a system called zero-knowledge execution. In ZXC, users execute state transitions offline. This process produces a proof which is bundled into an on-chain transaction. This transaction updates the state of the system by consuming, creating on-chain records. Like Zcash, the system gives us strong privacy guarantees, as the transactions contain only the proof, not the input that generated it. And like Ethereum, ZXC can support smart contracts that enable users to interact or transfer value in a predefined way. For example, let's say you want to trade token A for token B on an Aleo-based DEX. First, you will need to prove to the DEX that you have enough of token A in your possession to complete the transaction. But because this information can be shown through a zero-knowledge proof, this doesn't mean revealing your wallet balance or trade history. Instead, you can reference an on-chain proof a record of a prior transaction to show that you have a sufficient balance to trade. In the process, the exchange never learns the amount of tokens you own, where you got those tokens from, if you ever transacted on the DEX before. Altogether, this creates a DEX ecosystem that is not only entirely private and scalable for users, but also replicates a key feature of smart contract blockchains, like Ethereum, composability. Some more examples. Imagine a situation that Bob wants to buy alcohol in a bar and the bartender asks him to show documents to make sure that he has enough years for this. He shows him his passport and the bartender sells Bob alcohol. But when Bob shows his passport, the bartender gets access not only to information about his age, but also learns other data, full name, ID, etc., such information that Bob wouldn't like to share. Zero-knowledge technology will allow him to independently choose which data he wants to make available and which not. In this situation, the bartender would not have learned anything superfluous about Bob. He would only understand that his age corresponds to the need to buy alcohol. Here is one more example. Suppose Bob wants to take out a bank loan to buy a house. The bank collects a large package of data about the client, and as a result, special algorithms form a credit rating, on the basis of which the bank decides whether to issue a loan or not. With zero-knowledge proofs, the bank will not see any extra information about Bob. They may not even know that his name will be Bob. What they will see is that Bob's rating corresponds to the minimum required values. Let's summarize. Aleo is a blockchain that allows using zero-knowledge proofs technology to preserve the privacy of users as well as to create an opportunity for developers to create modern dApp. Users have never had such opportunities to control personal data in the entire history of the internet. Aleo gives full control over the input and output data that users will generate when interacting on the internet. Aleo has also created a special environment and programming language that allows developers to easily implement this solution into their existing products as well as create completely new ones. Thanks for your attention. Follow the news about the project by following the links down below.